of you. Hope you had a good day. In today's video, I'm going to introduce homogeneous functions, and I'll start with the definition of homogeneous functions. Specifically, a function f of x1, x2 up to xn is said to be homogeneous of degree k if f of tx1, tx2 up to txn can be written as t raised to the power k f of x1, x2 up to xn. The most important examples of homogeneous production functions are those for which k is either equal to 1 or k is equal to 0. If k is equal to 1, then that is known as homogeneous of degree 1, and if k is equal to 0, then it is said to be homogeneous of degree 0. In other words, when a function is homogeneous of degree 1, a doubling of all its arguments doubles the value of the function itself. For functions that are homogeneous of degree 0, a doubling of all its arguments leaves the value of the function unchanged. Functions may also be homogeneous for changes in only certain subsets of their arguments. That is, a doubling of some of the x's may double the value of the function if other arguments of the function are held constant. Usually, however, homogeneity applies to changes in all the arguments in a function. Homogeneity is related to the idea of returns to scale. Let's focus on constant return to scale. A production function exhibits constant returns to scale if whenever we increase all inputs in a given proportion, output changes by the same proportion. In equations, let function in the domain of non-negative arctant is a real valued function. It exhibits constant return to scale if f of tx is equal to tf of x for every x in non-negative arctant, and for positive t, that is t is greater than 0. A theorem is here. Suppose f of tx is equal to tf of x for all t greater than 1, then f of tx is equal to tf of x for all t greater than 0. So it means that if t is greater than 1, then f of tx is also equal to tf of x for t greater than 0. And the proof is here. Equation given above trivially holds for t equal to 1. Now suppose 0 is less than t is less than 1, then 1 by t is greater than 0. So f of x is equal to f of t raised to the power minus 1 times t x is equal to 1 upon t f of tx, which implies t f of x is equal to f of tx for 0 is less than t is less than 1. Constant return to scale functions are also called homogeneous of degree 1 because we multiply function by t to the first power. Similarly, a function is homogeneous of degree gamma if we multiply function f by t raised to the power gamma power. More formally, a homogeneous function on non-negative arctant, a real valued function, is homogeneous of degree gamma if f of tx is equal to t raised to the power gamma times f of x for every x in non-negative arctant and positive t, that is t is greater than 0. The degree of homogeneity need not be an integer. It can even be negative on strictly positive and dimensional space. Constant return to scale functions are homogeneous of degree 1, as I mentioned earlier. If gamma is greater than 1, homogeneous functions of degree gamma have increasing return to scale, and if 0 is less than gamma is less than 1, homogeneous functions of degree gamma have decreasing returns to scale. However, many production functions with increasing or decreasing return to scale are not homogeneous, such as function f of x is equal to x2 plus x raised to the power 3. this is not homogeneous. Cobb-Douglas production function defined on non-negative orthant have the form f of xy is equal to ax raised to power alpha y raised to power beta, where x may be thought of as capital input and y may be thought of as labor input. With a, alpha and beta is greater than 0. Here a is efficiency parameter or productivity parameter, and alpha and beta are distributive parameter. Then f of tx ty, that is, if we increase both inputs by t, then we can write the right hand side a times tx raised to the power alpha times ty raised to the power beta, and then we can say we can factor out t raised to the power alpha plus beta a x raised to the power alpha y raised to the power beta, and that is equal to t raised to the power alpha plus beta times f of xy, which shows that function is homogeneous of degree alpha plus beta. If alpha plus beta is equal to 1, then there are constant return to scale. If alpha plus beta is less than 1, then there are decreasing return to scale. If alpha plus beta is greater than 1, then there are increasing returns to scale. So we can generalize this to non-negative orthant or n-dimensional positive n-dimensional Euclidean space. Cobb-Douglas production function are on non-negative orthant have the form f of x a product I varies from 1 to m xi raised to the power gamma I, with each gamma I greater than 0 and a is greater than 0. Such a function is homogeneous of degree summation I varies from 1 to m gamma I on non-negative orthant. Again, it exhibits constant return to scale when summation I gamma I is equal to 1, increasing return to scale when summation I gamma I is greater than 1, and decreasing return to scale when summation I gamma I is less than 1. So ladies and gentlemen, this is a brief introduction about homogeneous production functions or homogeneous functions. I hope this was quite informative for you. Kindly subscribe to the channel, and don't forget to click on the bell icon so that you could get regular notifications about my other videos that I'll upload for you. Thanks for watching this video. Kindly share various videos of this channel in various WhatsApp groups and on social media.